Hello all, welcome to all of you in this EDA 2022 summit. My name is Eknath Vashishtha and I'm going to talk about ANZ Payments EDA Journey. And before I begin, first I would like to greet you good morning, good afternoon and good evening, since you are joining from different part of the world. So let's get started. And before get started, let's introduce who are we and what exactly we do. So ANZ is a primarily bank, which is headquartered in Melbourne, Australia. We are offering a banking and financial product to our 8.7 million customers, namely in retail and corporate space. Our operations are spread across 32 different geographies, and our core employee strength is close to 46,000. Our people, purpose, value, and culture make us ANZ. The way we have structured our division is something like this: Australia retail and commercial, institutional, and I am coming from payments domain, which comes under institutional. New Zealand Pacific, technology service and operations, and group center. Our purpose is to shape the world where people and community thrives. Now coming to payments domain. In ANZ's payments domain, we offer payment services to our customers across 32 different geographies. Namely, these payments underline offering domestic payments, international payments, faster payments, and number of different services based on the geography. We are constantly challenged by our peer banks and a lot of fintechs. So innovation is one of the key things. We are constantly innovating technology to make sure our product and service offering to customer is reliable and convenient to use it. When we look around our technology landscape and services offering, this paradigm, how does it appear, is technology, data risk management, digital ready infrastructure, intent to provide great customer experience with the system and the process that is less complex, less prone to error, and more secure in nature. We simplify what we do. We reduce number of systems that we are operating on. We are cutting the length of customer terms and conditions by using right tools and technology to provide great digital experience to our customers. Now coming to event-driven architecture, how exactly EDA has been positioned in ANZ payments domain. Before we get into that, let's try to understand the premise of EDA. And I would like to roughly go back in time, 3 years and few months approximately. Right. So by the time how our technology landscape appears to be, one way we have a big monolith application, homegrown, which has a core payment capability built in-house. On another way, we also built up another new platform that's on the microservices platform. Intention was to make future-proof, ready in terms of technology and the function aspect. And we had been surrounded by a number of different systems which offer supporting functions like fraud, core banking systems, and largely a legacy application running under mainframe, AS400, distributed systems, and likewise. So this is how we had been positioned. We were undergoing through a journey, a major transformation, migrating capability from monolith platform to microservices platform. And this itself is a big journey which was underway. How we have adopted integration is we inherited integration historically, which is point-to-point in nature. And point-to-point in nature, I would like to just give an example is, let's say I have a service A, wish to call a fraud check service. How exactly we used to call is, first we used to look around our DB, what is the endpoint for the fraud check service? We would like to figure out what is the queue name. We used to post a request. We used to expect a response and reply to queue, wait for the response, and then do next thing. Likewise, every service communication was point-to-point, and a common segment, a common event which is to be go to a number of different places happen to be point-to-point. On top of that, we had been continuously enhancing our platform and systems. Enhancement by introducing new business capability, that is a new business function offering to a customer, or change suggested by regulators, industry, or there is a change which is suggested either by internal security guidelines or industry security guidelines or regulator security guidelines. Now, interesting proposal was volume growth. Our platform and system has been continuously experiencing volume growth. The easy way to understand volume growth is primarily into two segments, internal and external. Internal volume growth, we fairly know what exactly it is because our channel systems, which are going to introduce volume, we roughly know what is the volume which we are going to experience, our systems are going to experience, either batch or online. There is also a segment of external volume growth, which is not in our control, and we don't really know much on that. So just an example, a payment request, which has been originated outside of ANZ and expecting that payment request to come to ANZ to credit to ANZ customer. Now, such volume growth is largely controlled by different bank, third party, or other financial institution. And this kind of volume could be either online or batch in the nature. And there could be mix of it. Example, online is systems are pretty easy to operate. Batch, either batch will be given or a batch is available to other financial institution. They are slicing into singles and coming, traffic is coming to our system. Now, in any of the given aspect, if volume is online in nature, it may cause a flood in our platform, payment processing platform. If it is a batch in nature, it might experience a hammer kind of impact. We also been surrounded by a number of different SLA for payment transaction processing. Example, international money transaction, which has a little longer SLA. That is a cushion to us, but there is a faster payment. That SLA is largely very, very short. Generally, it is 15 seconds across bank to bank. And in 15 seconds, if it is inward payment or outward payment, the SLA within the ANZ network comes right under 5 seconds. Depends on the type of product. And this kind of faster payment service we are offering across multiple different countries since our operations are spread across 32 different geographies. Service reliability, fault tolerant system is inevitable. The systems which we are operating under our platform may undergo through maintenance, and this maintenance will cause a disruption. The system will be off either in a planned way or unplanned way, which might cause some service disruption. And how do we make sure there is no service disruption for the customer which is operating or the payment transaction that we are processing currently? Now, if I look at point number 765, this itself is a pretty much good indication in terms of overall service offering that we are giving to customer. And these 3 points are keeping always us on toe to make system platform better, robust, and able to cater all these requirements at any given point of time, whether it is a planned or unplanned. Now, on top of that distributed workload, this is a bit of an interesting journey. If we look back 20 years from the time now, all of us has been trying to say globalization. Globalization was bringing everything together. Now, since past few years, a lot of countries, lot of regulators, everyone is largely talking about localization. There are a number of factors because of that, but since the product and services that we are operating and kind of geography that we are operating, we are compliant to all the regulatory guidelines. As a result, we have an on-prem setup, global, regional in nature. We have a cloud setup, global and regional in nature. Now, if you look around all potential aspects, there is a quite number of different challenges and how we solve. We solve these challenges in many different ways, but one of the way which we have solved is using event-driven architecture. And how exactly EDA has solved many of these problems, let's get into that. Now, coming from the background of point-to-point integration is largely a fixed endpoint. no publish subscriber. Now getting into publish subscriber, how we started our journey. Let's look into that. The first and the foremost thing is if we are changing from queue to topic, the most important aspect comes is what should be my topic name. Now the topic name fundamentally should be aligned in reference to business function. But what are my business functions? So here we are supporting two platforms. Platform one, which is core payment processing platform, driven by industry SLA, transaction processing, uh, unit of work, and number of different things. And second aspect is the core data platform. So core data platform has received data from core payment processing platform and does many functions like regulatory reporting, trend analysis, business related, business function related analysis, reports, and number of different things. On top of that, since we are writing core services, which are functional in nature, but many times we need to integrate one service to another service, more like a tech event, there is no functional connect here. These 3 points itself given us a quite significant input. And when we started our journey, how exactly we aligned is we designed topic hierarchy in such a way which is very much functional in nature. So when I say functional in nature, example, a core payment processing function involve a function like fraud check is one function, clearing, settlement. So can I have a topic hierarchy which is depicting all these unique operations independently? And data platform on the other way has altogether different function. Example, they are interested in specific statuses of the payment. A payment need to be warehoused, a payment need to be completed, a report need to be generated, and likewise. There is a fair bit of a mix, but there is a fair bit of a uniqueness. However, we design topic taxonomy fit in for all these two segments. Also, this topic taxonomy has been aligned to fit in the technical aspects, which does not fit into payments domain functional aspect. However, that topic taxonomy was decent enough. Now, what exactly we did next? Now, historically, we had been coming from background of point-to-point integration. In point-to-point integration, what exactly mean is a service A when we are sending a request for fraud check, either we are changing a format which can be accepted by fraud check, or we are sending in a format which fraud check has to receive, transform, and operate. Perhaps there were a lot of different formats being used, and what we realized is by using different format is compute expensive in terms of transformation, and we have an opportunity. Can we have a canonical data model? So we started working on canonical data model. We came with a canonical data model which fit in for two purposes. One, fit for payment transaction platform, a universal data model that can address our domestic payment, international payment, faster payment, or any type of payment perhaps. And second is a data platform, which is having a data related need, how we would like to notify these event to other system, other consumer. Can I have a canonical model? And in between inter-service communication, we started using these model. What exactly we realized is we cut down that entire compute operation which require transformation. On the other hand, what exactly we noticed is our communication has been a bit faster. Now, third interesting aspect was a framework enhancement. Our core framework is deployed into microservices platform. And since we are building two independent platform, transaction processing as well as data platform, the requirements are nearly same, but they are slightly different in nature. Let's get into what exactly the commonality and let's get into what exactly the difference altogether. Since we are into banking services, our transaction, our unit of work, our transaction boundary is very, very important to us. We cannot lose a transaction in halfway or during middle of the processing. So what exactly we do and how exactly we do? I would like to give a simple example. Let's say we receive 10 requests. a payment transaction to a service. That's an input. And that input come from message-oriented middleware, either maybe MQ, Solace, or we have a multiple middlewares. We consume that event, we consume that transaction, we perform a business operation on top of it, we persist that event into database, we may require to send that event to next service in a row by their choice of message-oriented middleware, MOM. Now, in this entire unit of work, there can be possibility of failure at multiple places during execution of transaction. Example, we receive the instruction, we receive the payment instruction, we park that instruction into DB. However, while posting that response to next service, the MOM failed. What we should be doing? We had been parking such event into a different place, that this is a unfinished transaction, which has to be looked under some way or the other way. We would like to experience largely an automated way of self-recovering. If it has not been self-recovering for a period of time, a manual intervention would be taken care. So all such fine-grained nitty-gritty has been designed. Since Solace was a new adoption for us in our framework, we enhance our framework to accept Solace as one of the resource group and binding under the transaction boundary. We came with a plug and play library kind of a concept, which was helping us to make faster microservices next time if we have to build any microservices. Now, coming back to the need of transaction processing, the transaction processing platform demanding strong consistency of data. What exactly this means is a loss of system, a loss of service, a loss of platform. The data recovery has to be quick, efficient, and should be able to operate. Even if you are replicating data, it has to be synchronously replicated. Wherein the data platform was slightly relaxed, they offered eventual consistency. So we implemented eventual consistency for the data platform. In that particular sense, we got a little bit of a bandwidth and bit of a relaxation in terms of a platform. Now, coming to intelligent publisher. From point-to-point perspective, it was very simple, not so complex. But when I look at the publisher and subscriber, there are fundamentally two parties involved. One is the publisher, other is subscriber. In my opinion, publisher is lightweight and subscriber is heavyweight. How? So publisher is fundamentally has a ready event and able to publish to a target topic. When subscriber has to read that event and do a number of functions like pass that, validate, enrich, store, and things like that. So before getting into subscriber, let's see how exactly we solve the publisher aspect. How historically we used to figure out the endpoint right from our DB. We used to look up our DB, we used to figure out the endpoint, and we used to post our transactions here. That we started avoiding. We thought, can we do different? Yes, we can do different. Publisher has entire data and event readily available. Publisher has complete knowledge about it. What publisher used to do is look at that data, identify what exactly the data element and contents are there, and derive topic name on fly. And publisher used to post that transaction into newly derived topic on fly. However, the topic and underlying subscription has been predefined, pre-configured into MOM. That's where we started avoiding a bit of DB lookup and started operation much more faster. That's an intelligent publisher. We started design and started implementing. Call reduction. Before I get into call reduction, first thing I would like to touch upon the consumer aspect, that heavyweight aspect. In consumer aspect, how exactly we optimized is, let's say one consumer system will be receiving event from multiple different topics and expected to do number of different things. Example, a consumer event coming, a payment statuses. If the payment status is successful, I have some process. If payment status is failed, I have some process. If payment status is expecting a warehouse, I have some another operation to be done. How we had been doing these things? We had been first screening the payload, deciding what is an expected operation, and used to do. We stopped doing all such things. So a consumer will consume an event from a queue. However, queue will receive event from multiple different topics. So consumer, when it reads an event from queue, first thing it will look around the header. From the header, we come to know what is the topic name, the message was published, and that was good enough insight for us, how to treat this message. We don't need to look around the payload, just looking at the header, we started processing consumer of facade logic underneath. So this made us very smart consumer. Now, what exactly we achieve in terms of performances? The first and the foremost thing is what we noticed is 30% reduction in service deployment. When we deploy our service into OpenShift, we deploy 30% less instance compared to previous architecture, which was point-to-point in nature. What also we noticed is our event distribution across platform has been nearly 80% faster. And overall service operation example, when the payment enter into platform and after complete processing, when the payment leaves platform, overall time improvement was close to 80%. What also we noticed is a few other observation, and this is a simple comparison between previous point-to-point platform, previous MOM and current MOM with Solus. Certain occasion we noticed is subscriber was down. As a result, message started accumulating into queue. When the message started accumulating into queue and subscriber come online, a large backlog, large pile of messages, events are there. It takes a while to consume these events. We started noticing is the way we have changed our architecture and overall platform. This large accumulation consumption of message has been quite faster compared to previous message-oriented middleware and previous architecture. Scalability. Scalability is a simple answer if you have to address volume and all these NFRs. Now, all our microservices are scalable in nature. If we design microservices and deploy microservices scalable in nature to address NFR, generally it comes a back pressure to common services like MOM and database in terms of resources utilization like connection and overall transaction aspect. We made our platform more scalable. Microservices are anyway scalable. However, our MOM's message-oriented middleware also has a bit of a fixed capacity in past that also started scaling. So we had a choice of vertical scaling. Thanks to Solace, they upgraded number of transaction supports from 10K to 30K. Now, we not only do transaction processing and data processing, if at all we have to figure out what is the rate in which faster payment inwards are operating, what is the rate in which faster payment outwards are operating any business function, we can easily go to data platform. For some of the basic function, we stopped going to data platform. Perhaps we started leveraging our message-oriented middleware and their data available underneath. That's basically for trend analysis. So I would like to quote a few examples. Example, what is the rate in which fast inward payment are currently operating? We used to simply look around our MOM dashboards and just would like to figure out if we have to figure out when is the traffic high during day of week, a particular time of day or day of month, we can easily go and figure out, is this batch in nature? Is this for which country? What is the outward payment in nature? So all these basic stats and trend analysis, we can easily look around our message-oriented middleware and do all the needful things. Now, cloud is very interesting journey. Perhaps there is a lot of drivers and a lot of reasons that we are moving to cloud. Number of reasons like in today's world, we are heavily heavily surrounded by a number of different banks, number of different fintechs, and these are putting a lot of competition. And how to face these competition? How one of the quickest way is innovation, and innovation is one of the quickest and fastest way which we can do in the cloud. Perhaps there are a number of different reasons also, like uh, uh, local regulatory requirements also demands a local setup into in country that also can be addressed by cloud. So cloud in terms of on-prem fundamentally offer great agility, cost and performance benefit. It also offers a lot of interesting tool for data model modernization and quicker access to innovation. Since the time when we started adopting cloud, we came with a lot of key principles. I'm quoting here just two of them. So principle one, whatever we want to do, either we would like to develop a service in-house or we would like to choose a product, we want to make sure this particular product is on-prem and the cloud compatible. And our intention is anything what we do largely has to be in open source technology, either or containerized platform. Now, coming back to this point, to address a lot of regulatory need and a lot of different requirement, the way we have structured our workload has been scattered. Some workloads are available in global data centers. Some workloads are available to regional data centers just to comply with the local authority. Some of the workloads are available into regional cloud where we could not have regional data center. We have chosen the cloud. We also have global cloud. We have a BCP cloud and number of different things. How we are bringing a synergy in between them. Since our services and workloads are distributed in nature, let me quote one example. Let's say a payment request comes to a global data center, and intention is the outcome of payment has to be stored into regional cloud. So what exactly we do? We make sure global data center compute is taken care successfully. On completion of compute, we park event into event mesh and making that event mesh travel those events to a regional cloud, where regional cloud will consume and safely store. This is where we started leveraging benefit of compute operation, segregated compute operation. And one of the key thing which started leveraging is the topic taxonomy, the way we designed initially, that also giving us a core basic offering of event mesh platform and able to route our events across different workload. Similarly, we have a lot of functions and API, which are synchronous in nature. That's where API mesh comes into picture. Well, that's all for today. I wish you a great day and enjoy your day in this EDA 2022 summit. Thank you. Bye.